we are Team Trinetra. A lot of Indian cities face groundwater depletion and water shortages. While rainwater harvesting is a proven solution mandated by governments and government buildings and promoted by Ministry of Jal Shakti Abhiyan catches the rain, many people still don't know if it's actually a possible solution for their own homes due to lack of awareness and costly expert consultation, which makes assessing potential and performing cost benefit analysis too complex for an average citizen. This is where we come in picture. We are developing an AR/VR simulation through which user can easily input their required details and an animation which increases the understanding of our clients about rainwater harvesting process.
The following animation helps us understand our given problem, which is rooftop rainwater harvesting. As you can see in the following animation, the rainwater is collected on the roofs of various residential, industrial, or particular normal family household systems. The water which is collected on the roof is passed on to the gutters, which is passed on through the pipes to the filtering unit. The filtering units filters the given water, which is passed on to the primary storage tank, which we use on a daily basis. If the capacity of the primary storage tank is completely filled, the water is passed on to the secondary storage tank, which acts as a recharge facility. This water is stored in the form of groundwater. In modern terms, we call these secondary storage facilities as borewells, which can be used for using water throughout the year.
So the workflow for our solution or software is first we are going to take input from the user through our front end and then fetch it to the AI agent in the back end, which is going to calculate and generate a report which will be stored in a PDF format and given back to the user through our website or via his email. So this is how the front end website looks like. So here the user will enter basic details. So for example, uh, and example images. Then the property type, as in the residential, commercial, industrial, institutional, where the user wants to install the rainwater harvesting system. Based on this location and the latitude, longitude. So if the number of people are greater in the house, then obviously the demand water will also be greater. So for here example, I will enter 4. Then based on this latitude longitude, our model is going to calculate the average rainfall for that area. Roof area. If I enter 500, roof type as in the flat roof, sloped roof, mixed. So for example, I select flat roof, roof material. So this will matter because if the roof material is clay tile, then the cost of installing our system will increase. And if it is metal sheets, then the cost will decrease. So for example, if I select concrete, roof condition, excellent, good, fair, needs repair. I will select excellent here or good here. Daily water consumption. So on an average, a single person requires 55 liters of water daily. So for example, if I select 200 here, current water source, municipal, borewell, water tanker, mixed sources. The first plus means the first rainfall water requires to clean any dirt remaining on the roof. So this is the front end. I will press calculate my potential. Also, we have added a chatbot assistance. So if the user is facing any issue, the our chatbot will assist him. And this is the backend AI agent. So here, if the user presses calculate my potential, then the our backend AI agent is triggered. So for the input phase, via the webhook, all the input details entered by the user are validated here in this validate node. Then we are fetching a real-time rainfall data for that latitude longitude area via Open Meteo API. Then we are calculating average rainfall. Then also we have groundwater data which we are going to use. And then these all input details are then used for the calculation. So first, we are going to calculate the runoff calculation. Runoff means the amount of water that can be stored. Then we are also recommending a structure dimensions for installing the rainwater harvesting system. Then we are calculating cost estimation. These costs can vary from area to area or vendor to vendor. So for example, we have put these costs. Then all these details are then merged here. Then we are performing a water demand simulation testing, where it will check if the structure recommendations, the calculations done by our model, are they applicable for the user or not. So here we are testing it. Then we are suggesting recharge structure to the user. So there are basically three types of recharge structure: recharge pit, recharge shaft, recharge trench. Based on the input details, we are going to recommend it to the user. Then here we are using Google Gemini chat model to convert the JSON text, JSON code into HTML format. In this node, we are going to generate a report and then send this report in the format of PDF back to the user via his email or back to the website. So if I show you the website, this is the sample report generated by our model. It has given the structure recommendation, the runoff summary, the cost estimation. So based on the input given by us, the owner, it has given a cost estimation of about 26,000. This is the report generated by the water simulation testing. So for example, on the 30th of September, it is for that specific area, it will receive this much amount of rainfall. And if the demand met by the user, it is yes or no. So this much amount of runoff will be generated after installing the rainwater harvesting system and if the demand met. So this is the PD.
Our solution is feasible as AI agent uses real-time location-specific rainfall data from Open Meteo API, groundwater data, and aquifer data to make accurate calculations of volume of water runoff from rooftops, recommend most appropriate rainwater harvesting structure, its dimensions, and provide a range-based cost-benefit analysis, reducing the dependence of ordinary household and townships from the experts. It's scalable as OpenMeteo API can expand rapidly across any both rural and urban areas. The viability of our solution is reinforced by generating recommendations which are aligned with government mandates and central groundwater board standards to further simplify the local approval process from local authorities. It impacts citizens by empowering them with personalized immediate guidance, reducing dependence on tankers and municipal water supply system, creating a positive environmental impact. As the inclusion of Gemini chatbot assistance provides multilingual support and artificial recharge recommendations. It benefits the users by fostering sustainable water management habits. Thank you.